This example is going to come out of chapter 8, section 8.1, where we're solving systems of equations and we're solving them graphically. So the system I've chosen here happens to be linear quadratic, meaning one's going to be a straight line and one is going to be a parabola. These two are simple enough that you could draw them by hand. A slope of 1, a y-intercept of 7, I can draw that. And the bottom one is in vertex form, so we can see the vertex will be at -2, +3, and the parabola should face up. And so I drew those here, one in black, one in red, just so you could see them easier. It's not technically a graphing question, so I'm not going to worry about labeling a bunch of points and so on. But I can see, if my picture is at all accurate, that there should be two solutions to this system. The two solutions should be the points where these graphs intersect each other. So I can see there should be one intersection here and one over here. I'm not trusting the fact that I'm using no graph paper and so on, so I would put these into my calculator. y1 equals, y2 equals, graph them, and your screen should look something like this. Now, to find these intersections using commands on your calculator, remember we're going to use the second trace intersect. And we've used this a couple times so far this year, but just to remind you, second trace intersect. Then it's going to ask you for left bound, right bound guess. And in this case, this matters because you have two different answers you need to find on that screen. So to find the first of those answers, you need to move over close to that answer, hit enter, go to the right of it, hit enter one more time, and you should get a point on the graph where the two graphs intersect. So the first coordinate that I got here is -3, 4. Then I go back and I do it again. Second trace intersect. I go over to the other answer where I can see the graphs intersect. I hit enter, right bound, enter, guess, enter, and I got a totally different answer, which was 0, 7. And so there are two answers to this. And if you check either one of those answers in with the original equation, you'll find that both of them will work in both of these equations. In fact, that's what makes them unlike any other points in the universe, that they are the only 2 points that satisfy both of these equations. There are lots of points that satisfy the black line. There are lots of points that satisfy the red curve, but there are only 2 points anywhere that are on both of those two graphs. And so that's what you're going to do in section 8.1. Sometimes you'll have two parabolas, sometimes you'll have a line and a parabola, but you're graphing them. So show that you've done what you've graphed, y equals this, y equals that. Show that you're finding the intersection. Show how big a graph you needed. So in this case, regular window settings would suffice. From -10 to 10 in both directions would have been fine. And then probably most importantly, show that you find the answers.